Right, in this video I'd just like to show you some new modifications and upgrades I've done to my low-cost bench drill. Some time ago I did a video where I made a new depth stop assembly out of aluminium, and I also showed how to extend the height of the pillar at the back here to give you much more room on the drill. I've now made this heavy duty unit which goes onto the actual drill with one locking bolt. It's a dual purpose unit made of solid steel, and I have a quick movement brass thumb wheel with locking for the adjustment of the depth, and I have a special device here for the actual locking of the spindle so that I can use as much force as I want to on my keyless chuck. And this new keyless chuck here can take 16mm drills. It's one of the best quality chucks you can get, I think, and it's got super precision jaws on it and holds the tiniest drills, and like I say, up to 16mm. And when you fit a keyless chuck like this onto a bench drill, you'll find it's very awkward to actually hold small drills whilst doing the chuck up at the same time without the actual spindle moving. So I made a new assembly that goes onto the back of the chuck with 12 indentations around the diameter, and I can quickly feel for those indentations and lock that chuck up in any of those 12 positions. And like I say, I can put as much force as I like on it to hold the drills tight. And the locking bolt mechanism on the front here is spring loaded so that it cannot rattle loose. Now, I never really use the different speeds on my bench drill. I only ever use the slowest speed, which is the belt on the lowest part of the pulley. And I've removed the top half of the tin guard, and I fitted this heavy cast iron hand wheel. I got this hand wheel off of an old electric sewing machine, and I bored a counter bore in the cast iron pulley, made up an aluminium adapter to fit that bore, and secured it with Loctite 638. That adapter is threaded down through with 8mm thread, and then I bored this hand wheel out to suit that assembly, and it's screwed on with a 8mm Allen bolt down through the centre. And I use this hand wheel to start off taps on the drill and do hand tapping to actually get the taps nice and square in whatever I'm making. And for very fine screw tapping like 8 or 10 BA, I've made up this other handle assembly here. I made up an adapter out of dense PVC, used the existing bore that's in the top of the pulley here, and press fitted that in on the bench vise nice and tight. It's threaded down through with 6mm, and then an equal piece of brass over the top bolted on with that 6mm bolt. Two handles so that it's balanced and doesn't cause any vibration when the drill is in motion. And I can actually use this for very fine tapping. Gives me excellent feel over the work and saves any screw tapping breakages. And like I say, it's nicely balanced so it doesn't cause any vibration, and this is what it's like when the machine is started up. Now, one of the things which was really annoying with this bench drill was that the handles kept working loose. I threaded the steel a bit more down the shaft, 8mm, and put these stainless steel nuts on the end there and tightened those up, and that prevents those from coming loose now. I've also fitted a nice piece of thick brass tubing over the steel handles to give it a better appearance and feel, and also fitted these dense PVC ball ends that I've made on the lathe. And I think I've shown this before, but I'll show it again just in case you haven't seen it. I always use a scissor jack under this table whenever I'm drilling, and that's because these tables are very prone to flexing, even on the bigger drills. And so I use this 2-ton scissor jack underneath, wind it up until it just touches, and give it a very slight little nip up. Don't over tighten it or else it'll bend it up, and that will prevent this from bending in use and causing inaccurate drilling. So now I'll quickly show you on the bench the various components I made, how it goes together, and how you can still get the chuck off of the spindle taper using this assembly. So it's all fairly straightforward really. I made this ring up out of a piece of 75mm diameter mild steel, which is 12mm thick. And I put it on the lathe and very accurately bored out this diameter here. This is the most important diameter, the clamping diameter. You've got to get that one dead right. And then a counter bore for the actual flange on the quill. Also on the lathe I used a 2mm HSS slitting saw to cut one side through and 2/3 of the way through the other side. So this saw cut here actually allows it to bend very easily when I do this bolt up, and with relatively no effort at all I can actually just nip that up, and that will actually lock solid onto the quill. When I had finished the ring assembly, I just put that onto the quill of the drill and just worked out where all the other components had to go. So I worked out where this 6mm thick disc had to go, and then drilled and tapped for those two securing bolts. I filed this one nice curve on here before I actually fitted it. So I got it quite close, then bolted it onto the ring again without this threaded part in there, put it back up in the lathe and bored it out so that this diameter here would actually blend in nicely with the existing bores. And one thing I had to take into consideration when I put this assembly on was to have the bolt holes one side of this bending slot so that it didn't counteract its purpose. And this is just another piece of mild steel which I threaded the front part with 8mm thread that goes through the flange and nips up with a nut there, stainless steel nut. That's threaded through for 6mm. I used a 6mm bolt, made up a brass nut there which screws onto the bolt, Loctited that on, put a spring in between, and that's the actual locking assembly. And the threaded part here is just 8mm studding. I turned it down to 6mm this end, drilled and tapped through the disc, threaded it for 6mm, that bolts through and locks up with a locking nut that side. And the keyless chuck that I bought is this one here. You can see the lovely jaws on it, absolutely close right up so you can take the smallest of drills. I took this collar off here. It's held on with one grub screw onto an indent on that diameter there. Turned this one to fit that diameter nicely. This face here locates on the back face of the bore, and the grub screw goes into the existing indent and locks on. And when machining that, I've left a gap between this face here and the back face of the chuck so that when I operate it, it actually doesn't rub. And the thing, or the main thing I had to consider when making this was how would I actually get the drill chuck off of the drill taper when I want to take the chuck off. I made this diameter so that it was slightly bigger than the bore diameter. I can undo the nut here. This assembly drops down onto that actual collar, and I can use a mallet to actually knock the chuck off of the end of the taper. So first I undo the 10mm locking bolt at the back here, and that will drop down onto the flange that I made on the adapter, and then just give it a tap, and the whole assembly comes off like that. And the last thing I made up was this brass adjustment nut to go on the 8mm studding, and put the tap through a few times both ways so that it can move nice and easily on the thread. And I've put a hole right the way through it, which I can actually put a small brass bar in to actually lock the nut on the top, lock it in position with a spanner to get a certain depth. So now on the Myford ML7, I'll show you some of the setups I used and the basic operations I used to actually make these components. Right, so I drilled my billet with like a 1-inch drill. Then I opened it out with a small boring bar like this one here. These tend to chatter a bit. As soon as the hole is big enough in diameter, you can go over to a larger size boring bar like this one here. These are very good boring bars. You can get these for under £7 from China, including post. They've got nice clearance on them, so you can actually use them for actually doing a bore and doing undercuts as well. And now I'm coming up to size on there, I can actually set my caliper clock to 1.570, which is the diameter, and I've zeroed that one, and I can check the bore and see how far I've got to go. Another 35 thou. To keep a nice finish, I take the boring bar off and don't cut on the reverse cut. And that looks very close. So before I take it out and try it on the drill, I'll just skim this face and chamfer it so I can put it back in and it'll run true. And because I'm working inside the jaws here, I'll use this HSS 45 degree tool. So now I can take it out and test it on the drill diameter. So next I'm going to set up my milling attachment on this lathe. Mill a flat in one side here so that I can centre drill it and drill and tap for the locking screw in one side, and also the centre locking screw for the spindle lock. Right, to save time and because there's a lot of overhang from the actual milling vise, I ground this right angle out here on my grinding wheel and then filed it nice and square and then cleaned up with the end mill. And now I'm going to centre drill down through and tap for 6mm thread. So now I have a clearance drill for a 6mm thread, and I'm going to drill down from this face to just past the centre, and to do that I just touch the drill on that face there and then use my stop and measure 21mm, which is the depth I need, between the carriage and the actual stop. And lock that one up. And because I've got that depth of clearance hole for the 6mm thread, I can use that as a guide to do the tapping and finish this on the vise. So now I have the component set up again in the milling vise. I've got a HSS slitting saw which is 2mm wide, and I'm going to saw through into the centre on this side, and I've set the lathe for 300 RPM. And now I've turned the component around in the milling vise, and I'm going to saw halfway down, and this saw cut is to allow this to spring easily when you do the bolt up on this side. Right, so this is the setup I'm using to do the 12 equally spaced indents around this diameter here. I've got my keyless chuck holding a piece of 1/2 inch brass bar, which is held in the jaws of the chuck here, and the live centre in the back of there. And I'm using my indexing plate, my pin assembly, a battery drill, and a round nosed end mill. And I've been around the diameter already and done the centre drill holes. And I'm going to the same depth each time, zeroed on the cross slide. And that's the 12 indentations done. Right, to do my drill handle ball ends, I'm using dense grey PVC, and I've got 30mm diameter, and I've faced it off both ends until it's 28mm long, and I've drilled and tapped it just over halfway down with 8mm thread. So I've got my 8mm mandrel in the chuck, and this one will screw directly onto that, screw it up nice and tight. And you want plenty of these mandrels if you're doing ball turning, and all different size threads, and it actually keeps the component well away from the jaws to allow the actual ball turning attachment to work without actually clashing the jaws. So I touch this one on the end face. I've already set this one up, lock the carriage, and then wind it out. of medium emery just to get the lines out. It gets a bit hot when you're doing this. Some 150 wet or dry, and I found to get a good finish you put a bit of oil on it. And that's the job done. And when you fit the new chuck to the taper, you want to make sure you don't do any damage to it. Make sure the tapers are nice and clean on the drill and actually inside the drill chuck. And I put a piece of brass bar into the chuck, pushed up to the end, lock it up nicely, and then put it onto the taper and use a copper mallet onto the brass to actually seat the chuck on the taper, and that will prevent any damage to the end face or the jaws of the actual chuck.